Hello everyone, I'm TongWang. Now let me introduce to you our achievement in Cantemist 2020. This title is the Paranoid Attention Model for Tumor named Entity Recognition in Spanish. I will introduce it from the following four parts: task description, our model, experiment, and summary. First, let's introduce the content of the task. I participated in the Cantemist NER task, which requires finding automatically tumor morphology mentions, and the corpus contents of the 3,000 clinical case and the professional clinical code classified. Annotate this clinical case in Spanish with the ECIEO 3.1 codes using the P.R.China annotation tool. Next, we will introduce our model. Before introducing the model, there are four problems to be solved for tumor named entity regulation. First problem is how to level 8 out of vocabulary problems. In our model, we use the connector embedding to supplement word embedding. It can represent all the information to a certain extent. The second problem is how to make the model more lightweight. We used the RN module to replace the most popular model BERT to extract text features. And the BERT contains a large number of parameters. The training cost is huge. RN can greatly improve the model training speed. The third question is how to better extract context-dependent information. We use the CNN to extract local dependencies information and RN to extract non-distance dependencies. And finally, merge these two parts of the information through the attention module. In this way, we can get a more comprehensive context information. The last question is how to reduce the redundant information in context dependence. We use the attention structure to assign different weights to long-distance dependencies and local dependencies, which can reduce the weight of useless information. Then we can understand the structure of the entire model through this picture, and our model contains four modules: embedding layer, pyramid layer, attention structure, and the classification layer. Next, I will introduce the experiment I did. We will verify the stability of the model and the credibility of the result through the comparative experiment, and use the Affiliation study to verify the effectiveness of the RN and the CNN modules. From the data in the table on the left, we can clearly see that our model have the better effect than BERT, while reducing the cost of training. From the data in the table on the right, we can see the rationality of the CNN and the RN modules. Finally, I will make a summary. We aim to build a model for the problems existing in the NER task, which have a good performance will be lightweight. For future work, our team hope to compare the model with the more advanced models and verify the effectiveness of the model on the more data sets to improve the generalization compatibilities. Thank you for your watching and look forward to your success.